Alright, so to make a motor, you want to use a copper wire to make a loop. The loop should be around the size of your finger as shown. Make sure to secure the loop by tying both ends of the wire back around the big loop. Now next you want to use a toothpick and put it through the loop. This is kind of acting as a shaft. Then you want to use sandpaper on the wire. Make sure you get both sides of the wire. And now you want to add glue to the end of the toothpick where it's being pointed to right here, so the wire travels along the toothpick. So next you want to glue down the paper clips as shown. Make sure they're at an appropriate distance apart from each other. And notice how the paper clips are bent down to ensure that they are able to hold the shaft. Now at this point you want to add the magnets to the middle of these paper clips, once again making sure the distance is good. And you want to place the shaft into the paper clip holder that we made earlier. Now you want to place 2 pieces of cardboard acting as a barrier to the toothpick. Make sure you leave a small gap in between the cardboard and the toothpick. Now place a small piece of tape by the paper clip as shown. This piece of tape prevents the wire from spinning the other way. Next you want to attach one end of the battery to the switch, which flows to one end of the paper clip, and then attach another wire to the end of the other battery to the other paper clip. To start your motor, all you have to do is flip the switch and give the copper loop a little tap. Here's another clip of our motor spinning.
So how does this motor work? The wire that goes through this coil is connected to one half of the shaft. Here we can see that as the shaft spins, current flows as the wires on the sides contact the paperclip. When the wire is contacting the paperclip, magnetic flux is decreasing because the area of the coil that is parallel to the magnetic field is decreasing. According to Lenz's law, the coil tries to oppose this by increasing the magnetic field. Using right-hand rule, we can see that there is a force on the bottom part of the coil going to the right and a force going to the left on the top of the coil. Since the shaft is secure, this causes a torque to spin the motor. A key element for this process is the piece of tape placed on the paperclip. This is to prevent any force going the opposite way and stopping the motor from spinning. Since magnetic flux can increase or decrease as the motor spins, there will be a clashing torque. This will cause it to turn forward and backwards without any real spinning. The tape acts as an insulation, so the wire only conducts current for one direction of magnetic force. This results in a consistent spin.